To slide open the movable auxiliary scale or movable jaw, hold the vernier in one hand and use your thumb to roll the jaw's adjustment wheel in or out. The movable scale should slide easily. Some calipers have a locking mechanism to secure the auxiliary scale in place, so if it does not slide easily, check to make sure that the locking mechanism is not engaged. To measure the length of an object, simply slide open the caliper's auxiliary scale and place the object between the large jaws. Then firmly close the jaws on the object and make your reading. To measure the outer diameter of a round object, such as a cylinder or sphere, slide open the caliper's auxiliary scale and place the object between the large jaws. Note that when measuring the outer diameter of a cylinder, the jaws should be perpendicular to the cylinder's length. This ensures that an accurate reading of the diameter will be made. If the jaws are parallel to the cylinder's length, it is quite likely that an inaccurate reading will be made. Once the jaws are properly closed around the object, make your reading. To measure the inner diameter of a hollow cylinder, such as a pipe or length of tubing, slide open the caliper's auxiliary scale and place the small jaws within the cylinder's hollow opening. Then expand the jaws so they make good contact with the inner wall of the cylinder and make your reading. To measure the depth of a hole, slide open the caliper's auxiliary scale and place the depth indicator into the hole. Adjust the auxiliary scale so that the length of the depth indicator is exactly that of the depth of the hole. Once the auxiliary scale is properly positioned, a reading may be made. Note that the length of the depth indicator is equal to the separation of the caliper's jaws. Most vernier calipers purchased in the United States give readings in both inches and centimeters. As always in physics, we will work with metric units. Like a meter stick, the vernier caliper is calibrated in centimeters with the minor or smallest divisions in millimeters. However, unlike a meter stick, the vernier caliper allows the fractional part of the smallest division to be accurately determined, not merely estimated. Using the vernier caliper to measure the length of an object is not as difficult as it may appear. The first line on the movable vernier scale is called the 0 mark. To make a reading, note where the 0 mark on the movable scale falls on the main scale. In this example, the 0 mark falls between the 6th and 7th major divisions on the main scale, so we know the reading will be between 6 and 7 centimeters. If we study the caliper more closely, we see that the 0 mark on the movable scale also falls between the 3rd and 4th minor divisions. Therefore, the reading will be between 6.3 and 6.4 centimeters. To accurately determine the fractional part of the smallest division, you must decide which line on the movable scale coincides with the mark on the main scale. Here you can see the second line on the movable scale matches a line on the main scale, so the fractional part of the smallest division is 0.02 centimeters. Therefore, the length is measured to be 6.32 centimeters. Try to determine the length of the aluminum block yourself. Here is the vernier reading as measured by one of our students. Pause the video now to determine for yourself the length of the block. If you determined that the length is 3.29 centimeters, then you were correct. If you recorded the length to be 3.28 or 3.30 centimeters, replay the video and closely observe that it is only the 9th line of the auxiliary scale which matches exactly with the division on the main scale. Therefore, the reading is 3.29 centimeters. Now try to determine the radius of this aluminum sphere. Pause the video so you can accurately read the vernier. If you determined that the radius is 1.12 centimeters, then you were correct. If you found the radius to be 2.24 centimeters, recall that the vernier measured the sphere's diameter, not its radius.